Hi everyone, we're here at my desk at home where I do all my electronic stuff. Got a few questions today on how we put together the Project B kit, so I thought I'd do a quick video on what all the bits are and how we can put it together. Okay, so I emptied out my kit on the desk here. Let's have a look at what's in there. So the first thing we're going to look at is the breadboard. I'll give you a closer look. So a breadboard is useful because you don't need to solder to connect components together. If you look very closely in the side of yours, and maybe you'll see it on here, we have these little silvered connectors. Now if you put a wire in any row, it will connect all the way along the row. So we can put, for example, get some component, stick it in 2 different rows, and it will stay there. Now we can take any other component and put it in the same row to connect its legs. So now we can have a little circuit. The only thing to remember is on these guys down the side, they're not connected horizontally, but they're connected vertically. So the one with the red line next to it will be connected all the way down. The one with the blue line is all the way down, and same deal on this side as well. Right, so the next thing we'll talk about is this little guy right here. This is called a resistor. If you've not seen them before, it resists the flow of current. Now we've given you a few resistors in your kit. I'll let you play around with them to find out which one is which, but let me give you a hint. The lovely EBS membership cards have the color code on this side. So if you have one of these, you can look it up. Otherwise, there's plenty of calculators on the internet. Work out how to calculate the color codes, and then if you look at them really close, maybe we can see it on here. They have tiny colored little bands. So all you need to do is put them in a calculator or something, you'll get the answer. We have these little KK connectors. So we have the flow sensor plug that comes on this end, and this guy will go into your proto shield like that. Now we have 2 kinds of them. We have a 2-pin one, so we can run 2 wires into the board, and 2 of these 3-pin ones. So the 3-pin ones are for the flow sensors, and the 2-pin ones are to connect the torque weight switch. Probably should talk about this guy. This is what we're building the project on. You'll see that it's got lots of little holes in it, and the holes will line up perfectly on these sides with your Arduino, and that's what this gold header is for. We've also got a thermistor. It's got the cool little coloured bands on it. It's not really focusing very well. There we go. Yeah, so this guy changes its resistance. It's one of these, but it changes it with respect to temperature. Now, in actual fact, all resistors are thermistors, but these particular ones have materials that have been chosen because they change a lot with temperature. These ones will change with temperature, but not really so much. This little guy, hopefully you've seen them before. This is an LED, a light emitting diode. This is not necessarily part of the project, but on your proto shield, if you have a look up in the corner, there's a little section to put an LED on. So I got you guys these green LEDs and a resistor to give you a little bit of practice with soldering, and I'll show you where they go in a minute. The last thing we'll talk about is this. It is an LM335 temperature sensor. Don't be confused with the way it looks. There are lots and lots and lots of electronic components that look exactly like this, so make sure you read the label to make sure it is an LM335. this is a different kind of temperature sensor to the thermistor. It doesn't change its resistance with temperature, but it has this semiconductor effect that we won't really go into, but essentially it changes the voltage across two pins with temperature. Okay, so we might get into putting it together then. So we have this proto shield right here, and the first thing we want to do is put our LED in there. That's a pretty good place to start. Now if you look at the legs on an LED, I'll see if I can get this to show up. One of them is longer. Now the longer leg is the positive leg. So if we look at our proto shield, and maybe we can see it, it's got a tiny little plus on there. Hopefully you can see it. So what we're going to do is we're going to put the long leg into the plus side, put the short leg into the minus side, just like that, and then you'll note that it sits nice and flush on the board. So what we do then is we hold it in place like so, bend the legs out so it doesn't move, and then it's pretty well, you know, it's not really going to go anywhere. So now what we want to do is connect it electrically to all these little gold pads on the bottom. So we take our soldering iron, this guy, and we turn it on. Don't forget to do that. Now your soldering irons will look a bit different to this one, but I promise you it's the same deal. So let's see if I can zoom right in on this. Alright, so this is how far I can zoom in with my lens. Only one thing I forgot to mention, blue tack. So it always helps to just hold everything in place with a bit of blue tack. And then hopefully your camera refocuses and we're ready to go. Okay, so we have our soldering iron and it's turned on. It's very hot, right? Mine at the moment is at 370 degrees. Yours in the lab might be a little bit different, but you just need to set it based on your solder. Now, solder, you buy big rolls of it. Ooh, how can I show you? Yep, we have big rolls. They come in all different shapes, sizes. There's another one. Here's a little one I have. Yeah, so you just need to, really the only thing is to make sure that the temperature matches your solder type. For lead-free solder, that's what they use at uni now. Generally set the iron to about 370 degrees. For leaded solder, generally set it to about 320 degrees. If your iron doesn't have a temperature control, that's okay too. You just need to be a little bit careful. Okay, so the basic technique to soldering is you get your iron and you get your solder, and what you want to do is heat up the metal pad. Remember, this thing's 400 degrees or 370. You want to heat up the metal pad and then at the same time push a bit of solder in. Now the solder will melt. Here, I'll show you. So it will melt and it will give off a bit of smoke. Now the smoke isn't particularly good for you, so I'm going to just turn this fan on that I have. Hopefully everyone can still hear me. So like I said, we want to heat up the pad, put the solder on, like so. And should join up. Now you'll find soldering the negative leg is the hardest, because it's connected to a big slab of copper. All this is copper underneath the yellow, and it sucks all the heat away from your soldering iron. So as it's trying to heat up again, this copper just starts to get warm. Now as we solder this side, it will be a lot easier. Yep. So now we have our LED soldered on nicely. Just make sure this guy's okay. Ooh, there's a lot of copper on there. Yeah, that'll do. Okay, so I'll lift this up so you can have a look. We've got 2 joints on there, and that's welded. This guy on the other side is not moving anywhere. So now all we need to do is get my favorite tool, some wire cutters, and we just want to cut the legs off, because otherwise they can touch other things and make it worse for you. Cut it off, and make sure you take off as much as you can, because the more that's on there, the more that will short on stuff. It's Murphy's Law. Okay, so to use an LED, we can't just have the LED, we need a resistor, and that's what this little R1 on the board is for. It's telling you to put resistor 1 there. So I will let you guys work out which one R1 is. It's the 330 ohm resistor. Maybe you'll see it by the color anyway. But it's the same deal, right? We just bend the legs to the right position, then push it into the hole. Make sure it lines up adequately. So the legs are through the hole. Come on, camera. There we go. So the legs are coming through the holes. So all we do now is we bend them out just to keep it kind of stuck in. So like that. And then we do our same thing. So I'll put this down on some blue tack. Turn my fan on again. And solder this guy down. Let me just check this one. All good. Now, same as before, get in there, snip the leads. You can turn your fan off as well if you have one. And there we go. So we now have our little power LED. If it comes back, a little power LED is soldered on. Now, what I think is a good idea is if we put on the Arduino connector. So this strip of gold pins, this is what we're going to use to connect into they call them boxed headers on the Arduino. So we gave you a lot of them because you need to cut them up to put them in each of these holes. So we need, how many do we need here? We need 6 down here. So I will count 6, hopefully correctly. Oh, jackpot. Okay, 6. Then we need another 6. Like so. Now we need, how many do we need here? 8. Now make sure that you take your time counting these because you can't reattach them, and I make this mistake all the time and I've been doing this for years. So I've counted these twice and made my other ones fly away on the floor. So in this last one we need to do another snip. And we've got them all. Okay, let's just try and move that up a little. Yep. Okay, so now what we want to do is put these guys underneath. Like so. So we want the long end to be poking out of the bottom, and the long end is opposite to the side that has the LED on it. Like so. as for which row you put it in, that is a very good question. I will get an Arduino and find out. Okay, so here's my Arduino. It doesn't look exactly the same as yours because it's a bit older, but one neat trick you can do is put all these gold pins into the slots of the Arduino, like so. Where's our other one? That's not it. Over here. So we should have all the gold pins sticking out the top, the short end, not the long end. And then we get our proto shield, and all we have to do is align this edge with this tapered edge here, and we just slot it on. Assuming that everything lines up nicely. Might need a little bit of a wiggle. And voila, it's on top. So now all we need to do is look at each of these pins and put solder on them all. So I'll try and do that quickly on one of them. So that one's all done. Now when we pull this board out, it's going to have all the pin headers welded into it with solder, and everything will be really nice and sound. I'm gonna pause the video, finish soldering this guy, and then we'll see it working. Okay, so I soldered it all up. All of these guys down the bottom and all of these up the top. Now let's plug it into my computer and see if our little green light turns on. Yeah, okay, so the reason we have this light on there is that so we can see there's power going on. Now there's another power light down here under this, but you can't see it from the top, and besides it was good practice getting this one working. Okay, so I pulled this off now. This is the thing we just made. This is our shield. So what we want to do to actually build the project is put stuff in all these little holes. Now you'll notice that all of the pins are really consistently, or all of the holes are very consistently spaced, and spacing up here was good, and well, all of the spacing on the board except for maybe that guy is exactly the same. Now this is what we call 100 mil spacing. It basically means it's 1/10 of an inch spacing. It's kind of annoying, but the reason we use inches is because when all this through-hole electronics was being designed, it happened mostly in the States. So it's not really done in metric for through-hole stuff. There's a special kind of electronics called surface mount. You can see the chip on here doesn't have any pins. This black thing doesn't have any pins that go through the board. Now that stuff is exclusively done in metric, and that stuff is what we use nowadays for modern electronics. So modern electronics uses metric, but unfortunately this through-hole stuff all uses imperial. Now what we need to put on the board obviously is our flow sensor connectors and our switch connectors. But I want to just point out that once you put something on here, it's pretty hard to undo. Like, it's possible and there are ways to do it, so come and see us if it is a problem. But to start with, I'd rather see that you guys didn't do anything on here other than the LED and putting the pins in. So that's where this guy comes in. Let's get him in. So you can put these in your breadboard. They'll fit in just fine. You can run wires from in the rows of the pins to other places, and you'll be able to prototype without soldering anything down, and that means you can fix it when it goes wrong, and it inevitably always goes wrong, so don't worry about that. Okay, so that was my attempt at a video. There's a few things I just wanted to talk about before we go. Your soldering iron, it's got some very special metal on the top of it, so what we need to do before you turn it off is just put a little bit of solder on it. It shouldn't be like a huge ball, but if we put a little bit of solder on it, then we can keep it good for next year's students, unless I guess your siblings are coming through next year, in which case you probably want to destroy them. Solder, I mentioned before, it has lead and lead-free types. It should say on the roll which one you're using. Don't be necessarily afraid of using either. The reason the lead-free solder was brought in is because in Europe they decided that all the lead in electronics was leaching into the ground soil. Whether or not that's true by the research is not relevant. All electronics is moving to lead-free, so that's why we have them. The leaded is a lot easier to use, but you need to be careful to wash your hands afterwards. That's really important, but hopefully you wash your hands after working on this stuff anyway. The last thing is that the fumes coming out of solder are not good for you. Don't scream if it goes in your face, but they're not good for you, so just try and avoid that and always work in a well ventilated area. I think that was everything. So if you have any questions for me, if you thought this was good and you'd like me to do a video on something else, let me know. I'll see how my thesis is going. But otherwise, talk to you all at uni.